go. We're dealing with special right triangles. In special right triangles, what we mean is we're going to start by talking about isosceles right triangles. Isosceles right triangles. What does isosceles mean? What do we know about isosceles triangles? Isosceles triangles. Remember we had equilateral, scalene, and isosceles? Which kind was an isosceles triangle? Isosceles triangle, if we have an isosceles triangle, we can draw one here. If it's a right triangle, it'll look something like this. We can call this A, B, and C. If it's a right triangle and it's isosceles, I mark it as these two sides congruent, and let's just say that these two sides, AB and BC, are 1. If AB and BC are 1, what does that make AC? Well, it's a right triangle, so I can use the Pythagorean theorem. A squared plus B squared equals C squared. Well, my A and B here are just 1. One squared is just 1, so this is just 2 equals C squared, which means C is equal to the square root of 2. Okay. Well, we can also talk about these angles here. And what do we know about angle A and angle C? If this is 90 and these are congruent, what do they both have to be? Good, Gavin. Yeah, they both have to be 45. So these are both 45 degrees. So we can tell it's an isosceles triangle by the base angle measures. If the angles are congruent, we know it's isosceles. Well, if the side lengths are 1, our third side is the square root of 2. And if we want to find any side, since these are the same, we're going to be only using an angle of 45 degrees. And here's what we need to know. The sine of 45 is actually equal to the cosine of 45. And let's figure this out. Okay, let's prove it to ourselves. What is the sine of A? Well, if I look at A, the sine of it will be opposite over hypotenuse. So we call this 1 over root 2. But what we want to do is we want to conjugate it, which means we don't like square roots in the bottom. So we actually have to multiply by 1 over root 2. I'm sorry, root 2 over root 2. Because this is just 1, right? It's just multiplying by 1. So if I multiply it by 1, I get the square root of 2 over the square root of 2 times the square root of 2 is 2. So instead of writing it as 1 over the square root of 2, we write this as the square root of 2 over 2. And if we look, we see the cosine of that same angle would be adjacent over hypotenuse, which is the same thing. So one of the angles that we need to know is that the sine and cosine of 45, so the sine of 45 is the same as the cosine of 45, is square root of 2 over 2. Okay, so instead of just relying on a calculator now for everything, what we're trying to do is find a couple that we can use and remember. And I'm going to teach you a key to remembering this, and you don't have to. So you don't have to remember it, but you can remember the key to figuring it out. Now let's talk real quick here about a different type of isosceles triangle. If this is an isosceles triangle, an isosceles right triangle, and I mark these as congruent. You can't see it, I'm working on it. All right. And if we call each of these sides x, if each of those is x, what we need to do is come up with a way to denote this side. Well, using the Pythagorean theorem, it would be x squared plus x squared equals c squared. Well, x squared plus x squared, that's 2x squared. If I were to take the square root of both sides, I would have to square root both of these pieces. So this would be the square root of 2 and the square root of x squared. But the square root of x squared, that's just x. So our side here is going to be x times the square root of 2. Okay. So that's kind of the flow of how this goes. We can progress from this. So this is the important things to really note from here are the sine and cosine of 45. All right, let's keep going a little bit here. And let's jump real quick to this. All right. Let's remember our SOHCAHTOA. SOHCAHTOA. Now, here's what we get. Sine, let's write it out actually. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Here's my question though. What is sine divided by cosine? Well, let's decide this using our ratios. Okay. So if sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, I can simplify this fraction. This is a fraction divided by another fraction. So we flip the second and multiply. We multiply by the reciprocal. So this actually becomes opposite over hypotenuse times, I multiply by the second one, but I flip it upside down, hypotenuse over adjacent. Well, if we were to multiply across here, we would see that these hypotenuse actually cancel out. And we get opposite over adjacent. Well, that's just tangent. So the point of this is to say that the tangent trig function, is also equal to sine over cosine. And that's a pretty big idea for us. All right, let's work with an isosceles right triangle here. I'll leave that there for now. So I've got ABC, triangle A, B, and C. These are congruent. This is a right triangle, and this is 6. Okay, if that's 6, we also know that these are 45. So this is a 45 in here. What is BC? Good, thank you. BC will be 6. Let's think about AC here. What about AC? Let's see what we come up with. Good, okay. Yeah, the square root of 72 is what we're looking at. Okay, but let's remember here, and I'm going to flip back to this page. We're going to write the square root of 72 slightly differently. When we're dealing with an isosceles triangle, if these two lengths are the same, we can write this third side length as the side length times the square root of 2. So if we look at this triangle again, you're right, it's the square root of 72. But what we're actually looking for is just 6 root 2. Okay, 6 times the square root of 2. All right, so let's do another one of these. If I tell you that this is 4, and these are the same, and this is M, N, O, what is MO? Thank you, Taylor. Thank you, Grace. Good to know you're here. MO is 4. What is mn? 4 times square root 2. And that's true for all isosceles right triangles. It's this number times the square root of 2. Okay, but we've got a different type of special triangle, special right triangle as well. And our other special right triangle is a 30, 60, 90 right triangle. Okay, and this is the one that we'll get to have some more fun with actually, because it's got 3 different angles in it. If I say that I have this right triangle right here, let's call it, we'll call it X, Y, and Z. We've got X, Y, and Z. Here's my 90. That would make this 60. And this would have to be my 30. Okay, I've got 30, 60, 90. 30, 60, 90 in a triangle. If this is the case, what we'll do is we'll call the short side A. In a 30, 60, 90 triangle, whatever number this is, if this is A, this will be A times the square root of 3. And if this is A, then the long side will be 2A. So before we get too far, I'm actually going to pop back into the warm-up question. Our warm-up question today said, what is the measure of LM? Well, if this is a 30-degree angle, I have a 30, 60, 90 triangle. If this is the short side, so it's opposite the 30-degree angle, if it's opposite the 30-degree angle, that's the short side, my hypotenuse is 2A, which is exactly what we came up with. The length of this is 10. So we've already seen how this can work. Let's pop back in here. So we've got a 30, 60, 90 triangle. And we can calculate ratios from this. So the sine of 30, let's just look at the sine of 30 real quick. In this case, what is the sine of 30? Well, sine means opposite. So sine is opposite over hypotenuse. So we'll have A over 2A. Yeah, there you go. Thank you. Now we're starting to get in there. And then good, Caden, that's exactly what I wanted to take next step here. We see the sine of 30 actually reduces to 1/2. Okay, let's find the sine of 60. Okay, very close here. A times root 3 over 2a. Good. Taylor, you're super close there. I think you just accidentally added 1a in there. So we get a root 3 over 2a, but these a's cancel out. So this just turns into the square root of 3 over 2. What is the cosine of 30? Is it the same thing as sine of 30? No. All right. It's the same thing as the sine of what? 60. Again. Good. Good. So it's the sine of 60. So the cosine of 30 is this over this, which is the same thing here. Root 3 over 2. What about the cosine of 60? Or cosine of 60 be? Here's our 60. A over 2a, or 1/2. Good. So we have cosine of 60, which is adjacent over hypotenuse. So a over 2a is 1/2, which is the same thing as the sine of 30. Okay, cool. So what we're going to do is we're going to come up with a way to remember these a little bit easier. And here's the best picture that I'm going to be able to draw for you. Oh, yikes. I'm going to get a little bit up so I can do this. And you can draw this same thing in your notebook as well if you have space. I've got my left hand down. Okay, so let's see if I can actually get this whole thing in here. I've got my left hand on the paper. Okay, so I'm going to try and like trace my left hand here. All right. Oops, messed that one up. It's doing so good. There's my left hand plus a nub. So I've got my left hand on my paper. Here, now it looks better. Well, we've got a couple angles that we really want to concern ourselves with here. Okay? And here are the angles that we're going to be working with. Picture this as a right angle. This would be 0 degrees from my right angle. So this would be 90. If this is 0 and this is 90, this finger here is going to be 45 degrees. That should make this one about 30 degrees and this one at about 60 degrees. And here's how we're going to come up with this. We're going to write a couple rules inside our hand here and say we'll do sine out here. Let's do sine up here. So here's our steps. put the finger of the angle down. So if I'm looking at my hand here and I want to find, so here's my hand. If I want a 45-degree angle, here's my 45-degree finger. I'm going to put my finger down. And then we'll count the fingers. Okay. So we put the finger of the angle down. Then what we're going to say is we are going to square root the number of fingers on both sides. Okay, so here we go. We'll go back in here. Put the finger of the number down, of the angle down, square root the number of fingers on both sides. And then we'll say this. Put it over 2. So what we're going to have is we're going to have a put it over 2. Cosine will be the fingers above sine will be the fingers below. All right, and this will make more sense here in just a second, I promise. So what I'm going to do is I'm going to say that I've got a big 2 in the base of my hand. So I've got a big 2 right here. Here's my 90. Here's my 60. Here's my 45, 30, and 0. Okay, so this is how we're going to think about our hand. Our hand is a trig calculator here. So if I want the sine of 60, I'm going to put the 60-degree finger away and then count the fingers. Sine is the fingers below. So how many fingers below do I have? Well, I've got 3 fingers below. So I square root the 3 fingers and put it over 2. So the sine of 60, let's do it. Sine of 60 is the square root of 3, not 30, of 3 over 2. So I have 60 square root of 3 over 2. What if I wanted the sine of 30? I put my 30-degree finger down. I have 1 finger left. The square root of 1 is 1. So the sine of 30 is 1/2. Well, that's what we just decided over here on the previous page. So I want you trying some of these on your hand here, and let's see if we can figure some of these out. I want to see if you can do this. I want the cosine of 45. See if you can use your hand to figure this out. I want the cosine of 45. if we look at our hand, cosine of 45 means I put this 45-degree down. Cosine is the fingers above. I've got 2 fingers above. I square root the fingers and put it over 2. Cosine of 45 is square root 2 over 2. Okay, you can ponder that a little bit later if you like. This is supposed to help us calculate some of our ratios. Okay, but let's do a couple example problems today and call that good. Happy to show you that a little bit later. All right, let's do a couple of these. You can draw one of these problems into your notes if you want, or a couple of these in your notes. I've got a 30, 60, 90 triangle here. 30, 60, 90. If I want RT, what is the expression I'm going to have to use to find RT? Or what can I use? Well, let's say I'm going from R. I'm going from R. Which trig function would I have to use to find RT? Good, I'm going to have to use sine. So the sine of 30, okay, so the sine of 30 is 4 over x. Let's just write this in here. We don't need to solve them all. 4 over x. But here's what I want to get through. Okay. The sine of 30 is 4 over x. Okay. So here's what I'm figuring out here. Sine of 30 is 4 over x. But what did we say the sine of 30 was? Well, if I put my finger down, the sine of 30 is 1/2. Square root 1 over 2. It's 1/2. So what can I say x is? Four is to 1 as what is to 2. So if I reduce this or make this into 4, I would say that it is 2 times 4, which would be 8. Okay, so we're trying to come up with some fun ways to remember special ratios. Okay, the value of x isn't 1/2. 4 over 8 is the same as the ratio. Remember, it's a ratio, ST to RT. ST to RT. Okay, so we said the sine of 30 is 1/2. We found the sine of 60. Sine of 60. Sine is the fingers below. 1, 2, 3. Square root 3 over 2. These are the exact values instead of just decimal answers. All right, let's get this last 2 tricky ones here. These are a little bit trickier. Remember, here's what we said. We said tangent is equal to sine over cosine. So if I want the tangent of 30, I'm going to run out of space here. I know I am. Maybe I'll do it right here instead. So if I want the tangent of 30, I can say that this is equal to the sine of 30 over the cosine of 30. Well, the sine of 30 we just said is 1/2. The cosine of 30, if I put 30 down, cosine is the fingers above, is the square root of 3, 1, 2, 3, over 2. Well, I can reduce that. Flip it and multiply. 1/2 times 2 over root 3 give us 1 over root 3, because these 2's would cancel out. Then I would have to multiply it to get rid of this root 3 on the bottom by root 3 over 3. These cancel out, or they would, right? But this is what we're looking for. Root 3 times root 3 is 3. So 1 over root 3 is really root 3 over 3. That's okay, Audrey. I'll post a video of it afterward. So the tangent of 30 is root 3 over 3. All right, let's take a look at a couple actual problems here that we want to try and come up with. All right, let's see. Let's do these real quick. I think these 4 will be pretty easy for us. And then we'll have a couple long answered questions. All right, what is the sine of L? Give me the ratio for the sine of L. Good. Thank you, Maddie. 12 over 13. Here's my L. I want opposite over hypotenuse. What about the cosine of L? Five over 13. Okay, so here's what we're looking for now. How about the tangent of M? Good. 5 over 12. So M, 5 over 12. And then the sine of M. Opposite over hypotenuse. That's 5 over 13. Okay, good. We're going to skip some of those, and we're going to go down to these last 3 problems. And as soon as we're done with these last 3, I think we'll be good for the day. So it's saying that the cosine of one of these 4 angles, either angle 1, 2, 3, or 4, is 0.28. Which angle is angle A? which of these angles would have a cosine of 0.28? So what we're going to do is we're going to take the ratios of each angle. If I start at angle 3 and I take the cosine of angle 3, I get 24 over 25. Let's see if I can get a calculator in here. 24 divided by 25, well, that's not 0.28. If I did 1, I would see the same thing. Good, so it is angle 4, because if we took 7 divided by 25, we get 0.28. Okay, so we're finding the angle that matters here. This is angle 4. Okay, the sine of a different angle is 0.22. Which of these angles has a sine of 0.22? Good, so we need 9 over 41. But now I want the sine, so I want to make this the opposite, which means this is angle 1. Okay, and we're not saying that the measure of angle 1 is 0.22 degrees, right? We're just saying that angle 1 has a sine of 0.22. All right, let's see if we can answer this one here. What is EF? EF, we're looking at this one right here. If this is 28 and this is 60, what could I do to find EF? What's the expression I would need to plug in? Okay, so this is, we could use sine. Sine could happen for us too. This is an opposite side. Okay, so if I was going to use 60, I would have to use opposite, which would make this the sine. So I could say the sine of 60 equal to 28 over x. This is x. Or you could use the cosine of 30. What we're trying to get at here is the sine of 60, or the cosine of 30, is root 3 over 2. So I can multiply it by 2 and divide it by root 3. And it looks like I get 32.33. Okay. And I don't think we have to measure all of these. Let's see if we can come up with a different way here. Let's see if we can do this a little bit quicker than on a calculator. And let me redraw this triangle here. Okay, I'm just going to redraw it. So we know we can do this using a calculator. But if I tell you that this is 28 and this is 60, what we want to be able to say is that we have an exact value. This is a 30, 60, 90 triangle. So if my short side is A, this long side is a times the square root of 3. This long side will be 2a. So we can actually figure out what a is here. Sorry, can't see that again. So using our 30, 60, 90 ratios, if the short side is a, this is a root 3, and this is 2a. I can figure out what a is. I can say 28 is equal to a times square root 3. So a, we'll just leave it as 28 over the square root of 3. That means 2a, I would just multiply it by 2. All right, I felt like that was a little convoluted today, and I'm sorry. I think we'll spend some more time on this stuff